Welcome to a new DIY Engineers video. Today I show you a smart map picture frame with a Raspberry Pi 5 that shows you pictures based on where you touch on the map. In this video I'll show you how I designed the frame, laser cut it, assembled it, set up the touch sensors, wired it, programmed in Python, and I'll test it as well. So continue watching for details on how I made this. So for the US map for this project, I went ahead into wikimedia.org and found this specific map. If I click on the link, I can then see the map on the right size and save it. And if I scroll down, you can see the permission, copyright, etc. So what I'm going to do with this map is I'm going to color the perimeter or anything outside of the map black. And as you can see, the edges are not super clean. So I have to go in with the coloring tool and color the edges black to make sure that once I import them into Lightburn, they come in correctly from what I'm trying to achieve. And this is what it's going to look like once done. This will be Alaska once done, and then Hawaii. You can see I cleaned up a bunch of stuff in the Northeast. This is what it looked like right after the download. And that's not really going to work well with the laser cutting process. So you can go to Google Maps and take a look at what it actually is supposed to look like and what you have there in the file, and then start cleaning up. So you can see I want to make sure the states are well defined, so I erase some of it, basically either erasing or doing the right click on paint with white, and then I'm just using the eraser, and then outlining with a little bit more ease the specific states that I want to show. And I mean, this black line is going to define where the laser cuts, so it can't just be some blurry thing. So that's why I'm having to make these improvements, and then just black out the rest and clean up as I showed you at the beginning. Here I had to do some more cleanup as well. Yeah, there's no way this specific section is going to be cuttable with the laser. So after that, boom, we're done with the 48 states. Had to do the same with Alaska and Hawaii, and that's it. So next step is to import the pictures. So I put them individually. Here you see 48 contiguous states. Once you import the image, place it where you want it, right click, trace image, play with the parameters and make sure that the edges are properly detected, click OK, and then you can move out the image, delete it, and you're left with the lines that will be cut. Ungroup them, delete the edge, regroup them to make sure that the states don't move relative to each other, and then continue the process. So then I went ahead and found an image, something to add on the bottom right corner. Don't ask me why they used distant O. And then I'm going to make that as an image. As you can see, the cutting, I'm doing 2.5 millimeters per second, and then 90% power. And then for the engraving, that's 50% millimeters per second at 60% power. That's for the northwest, east, south thing at the bottom right. And then I'm going to add here some text, call it memories. Cut it with the same parameters as the rest of the other lines, since that's the same parameters for cutting on basswood 3mm thick for my laser. And so this is going to be a non-cut line or square that I'm defining. I'm using a 300mm by 300mm piece of wood. So I just want to be clear as to, well, where's the wood at relative to the images I'm trying to cut. So as you can see, I have that blue square under the output on the top right box where it says cut layers. That output is turned off for the blue. Go ahead and save as a G-code. So if we go then to the preview, we can see quickly how it's going to do it, right? We set first the image engraving, and then it's going to do anything with the cut line on black. So this is just going to be optimized based on the laser, and you're cutting for the states, and then it's going to cut out the memories. And so as you can see, the overall cut is going to take about 44 minutes. So now let's go ahead and make the cut. And I went ahead and make sure to keep the small pieces that make up the E's such that it reads better. Here's the cutout of the O, and this is actually the piece that goes right there. So I'll put that here. There. And then I need to make sure to put the S. So I designed the front cover of the frame as a 3D model. Not super critical that it be 3D since the thickness is just going to be a 3mm thickness for my basswood. And then I go ahead and I turn this into a drawing, which I then took and made sure to save as a DXF that can be imported into Lightburn, making sure that the setting is set up on 1:1. Now in Lightburn, all I have to do is similar to what we did for the images, is just import and pick the DXF file. I'll go ahead and remove anything non-relevant. And then I'll go ahead and select and rotate 90 degrees. I then place where I plan to cut. Make sure my cut settings are how I need them to be. For my 3mm basswood, I'll be cutting at 2.5 millimeters per second and 90% power, and it'll be 1 pass. And so with this, we'll go ahead and file and save as G-code. So now we'll go ahead and cut the second laser cut piece. We're done cutting. Now let's take a look. So this is how the two pieces now go together. Next step will be to start painting. So here I paint the front cover. And here I stain the piece that will go behind the map for contrast. And so now it's really coming together. We glue the map to the backing. And then I'll add some weight to make sure they really stick together. With the map set, I add the final pieces of the letters. So now I went ahead and glued through some of the overlap that map panel to this front panel, and now the next step will be to place this on the main frame. And for the main outer frame, I'll be using the exact same frame I made for a previous project. The smart multi-picture frame with video that can detect the user using a motion sensor and camera with computer vision. This frame can then present the pictures and videos that are assigned to each user. Take a look at that video for full details. And here's the main frame. All I have to do is go ahead and put it right here. And let me lay it down. You can see how it looks. So then we'll add the screen there. We'll connect the electronics, the Raspberry Pi, and we'll be good to go. And the screen is not properly aligned, so I'm going to have to fix that. And so then for testing purposes, I went ahead and I duct taped each of the sensors to the location on the map where they belong. This took some trial and error to make sure that I got the location right. So after doing trial and error, placing it where I thought it was, tapping, make sure I got the right signal, I went ahead and placed the duct tape. And so I'll now run the test. But after that, we can go ahead and use the tiny holes in each of the sensors. You can see them right there to actually permanently attach it to our basswood sheet. This is a Raspberry Pi 5 setup for our 4 touch sensors TTP223B. All of them are connected to ground on the different Raspberry Pi 5 pins. Some of them are powered on 5 volts, others on 3.3 volts, and both are fine given they're both within the operating range of the sensor. And I have one connected to IO pin 14, another one to IO pin 17, another one to IO pin 09, and another one to IO pin 21. So we're here in the Raspberry Pi 5. Before I show you anything on the Python code or anything on the command terminal, I'll go ahead and show you the folder structure that I have set up for this project, which is important. Here I have a folder called projects, and then frame 2 is the one I'm using for this project. Frame is from a previous project. So under frame 2, I have several Python codes. Really, we're only going to be using this one, which is the one you need to copy and paste. And then under images, I have 4 folders, one for each sensor that I'm going to be touching on the map. And then an image called black screen, which basically fills up the entire image. The size is equal to the dimensions in pixels of my screen. And then I have a picture called bottom and one top. So for 0, I think this is Texas. So you have top and bottom. And what's key is that the pixels are at least greater in size than the pixels of the size you want to show in the image, so it looks good, and then that the aspect ratio is correct. So with that, I'll go ahead and show you how to run the code. So for this, I already created the virtual environment, and so to create a virtual environment for the one exactly I'm going to show you, I would have run Python 3.11 -m space vmv, hyphen system side packages, and then the name DIY engineering. Once that's created, that's what basically generated this folder called DIY engineering, which has all the right libraries, dependencies, etc. for that virtual environment. Once I enter it, basically to enter I do source DIY eng/bin/activate. And as you can see here, this gets me into the or shows that I'm in that virtual environment. If I wanted to exit out, I would do the activate. Now I'm back to my regular Raspberry Pi. I'll go ahead and get back in. And so we'll be running the Python code inside of this virtual environment. I would have to get to the right folder. So I would do cd projects. Now I'm inside the projects folder, and then I would do cd, what do I call it, frame_2. All right, and then I'm there. And so then to run the code, I would just run the right command to run it. So basically this one. Now before I do that, let me show you the code. All right, so here's the code. And for this code, you can go to my blog, DIY Engineers, and copy and paste it. But I'll be showing you here and explaining it what it does. So first we import several required libraries, so CV2, Pygame, Time, NumPy, and the GPIO, since we'll be using sensors. So I defined several functions for this code. A lot of them are similar, very similar to that last video I showed with the picture frame. So this one, aspect scale, basically will take the image that you want to show and scale it to the right size that you're trying to show on your screen. So this will use the proper scale factor, and this is going to be calculated by looking at this, which are the picture sizes that you define later in the code outside of the functions. So it'll look at that and use that to define how much to scale it down by, or in which way, whether horizontal or vertically. And then this is referring to the file name, and this is the location, kind of like what we talked. And then this is your screen size, and I have my screen set up in portrait based on the design of the frame. So anyways, back to the function, that will take the image and the picture number, where then the picture number, whether it's the top or bottom, will be used to basically, get the X and Y dimensions of your picture. You can see pic number and then 0 and 1, which is basically taken from pic sizes, which you defined earlier. And it's taking the 0 and the 1 to get the X and the Y, 0 being the X, 1 being the Y, based on how we entered it into the other array. And then if it's portrait, or depending on which one's larger, sorry, based on the image size, it will then go ahead and decide which scale factor to apply. So that's what this overall function does. Image to screen will display the image, so it will load the image with PyLoad. This is using Pygame. So it will go to the directory images that we looked at earlier. By the way, since you're running the code within frame 2, it's already in frame 2, and that's why you then have to specify images as this subdirectory. So that's what we say: images, user number / file names. User number will be entered into the function, and it'll be 0, 1, 2, 3, 4. You could create more if needed, but you'll have to obviously set up the folders, have the extra sensor, etc. So that will define which folder we pick here. So if it's user 1, we'll specify 1, and that's what the code is doing. And / and then file name, right? Which basically is either going to be top.jpg or bottom.jpg. Then scaled image will be basically the image that comes out after scaling it down using the aspect scale function that we just talked about. Blit will show the scaled image at the specific location, pick XY for picture number, and then the 0 and the 1, which is basically taking these locations, 0 being the 25 and then the 94, or 25 and 985, based on my specific screen and the specific location I'm putting in for the frame that I designed with the right cutout, etc. That's what that's doing here. So then this is just similar function, but just showing the black screen and sleeping for some time, which you will define as an input to the function. And then this waits for the touch. So we'll define it as wait for touch detected starts as false, and it will run for as long as the touch detected is false, meaning as long as nothing has touched any sensors. And then if any of the GPIO sensors are touched, this will be true. We'll define which sensor it was by calling sensor equals and give it a value, and change touch detected to true. Now if you touch it, all these should be false because you're touching one, and you shouldn't be touching two at the same time, since that's not the intent of the map. And then the while loop will see the touch detected is now not true, so it will exit and it will return the value of sensor, which is either 0, 1, 2, 3. 99 shouldn't happen because, or at least it won't exit out. If it's 99, it means that all these were false, so the while loop will keep running. Now, for the main code, you can see here we have the sensor pins assigned. These are based on where I connected it in the Raspberry Pi. Here we set up the mode of the GPIO pins that we're using. We'll start clock, we'll get the screen dimensions and pixels. We'll again define the picture size that we talked about, the names, and the location of the position, of the pictures relative to the top left corner of the screen, with the dimension measured in pixels. We initialize Pygame in here. We start with a black screen using Pygame color black, and then this gets into the main while loop, which will display a black screen for 2 seconds, wait for a touch. Now again, this touch has the while loop. Once something is touched, we will run image to screen for 0 sensor and 1 sensor, where sensor is the output of the function here, and 0 and 1, if we go again back to image to screen, is the picture number. If you look at the picture number, that'll define whether it's here, right? Picture number, that defines the XY position. Picture number goes into aspect scale to tell it which image, etc., etc. And then after showing it, we'll display it for 10 seconds, and then after showing it, it'll go back to black, and then you're supposed to touch another location in the map. So now let's go ahead and finish assembling the frame and running a test. So here's our frame ready to go with Raspberry Pi turned on, and we're in the command terminal about to enter the Python code. So we'll get right on with the testing, and you can see that once we touch Texas, the pictures come up, but they're not properly lined up. So my calculations were not 100% perfect. So we're gonna have to go into the Python code and edit real quick the specific location of each picture and retest. So now if we touch Texas, now it shows up the way we want it to. We touch California and we get a different set of pictures as originally planned. We go to New York, we get 2 new set of pictures. And then finally Florida, the final 2 pictures. So this worked exactly like we wanted to. Alright, so that's the video. I really hope you liked it. If you did, make sure to like and subscribe, and see you in the next one. Thanks for watching. Bye.